The next part of this section on volume, finding volume of odd shapes, I guess, is called the washer method. So now the washer method is used when the solid has a hole in the middle. So you use the disk method when you have these that we were looking at in the first video, where you're rotating this around one of the axes or some axis of rotation, and it creates a solid. There's no gap in the middle. The washer method is a little bit different because now we're going to have a hole in the middle. So we might see something like this shape. So we could have something like that. And then we rotate it around either axis, doesn't matter which one, but let's say the y-axis. And so you have this little crescent moon type shape. We're rotating it around. So we'll have this, and then we'll have this over here. So the mirror image, and then it just rotates and this would make kind of like a bowl. So it's not a solid shape. So when we use the washer method, it's because we have this gap between the axis of rotation and the shaded area that we're looking at. And so this doesn't change much for us. You could probably imagine what we would need to do. In this case, we would need to find the bigger radius. So the radius from the axis to whichever function is outer from that. And then find the radius from the axis to whatever function is inner. And then we subtract the two, and then that gives us the volume, or at least the radius that we need to look at. And so here we have the formula, v equals pi. So this is very familiar, integral from a to b. But now instead of r squared dx, we have big R squared, so the outer one, minus r little r squared, which is the inner one. And these are both functions of x again. I shouldn't write r of x, but it's functions of x. And so we integrate over this, and then it gives us the volume. So not too much different. Obviously, the disk method is going to have easier problems, but if you understand the disk method, and like I said in the last one, probably watch that one a couple of times and then work the problems for the disk method before you even look at this video. And I think if you understand the disk method well, this one will come a little bit easier. If you're trying to learn them all at once, I think it'll probably get confusing. So, all right, so let's look at find the volume. So we have y equals x squared, and we're going to rotate around the x-axis. So the process is the same. So we have y equals x, looks something like this. We have y equals x squared, looks something like this. And so here is our shaded region. And so most of these you're going to need to figure out where these intersect, because in the last one, a lot of times it was given kind of the limits, x is between 1 and 2, for instance. Here, we don't need to be given that because this is a closed region just with these two curves, or the line and the curve. So you can set these equal to each other if you like. It's probably pretty obvious what you get. You get x is 0 and x is 1. So those are our limits of integration, and we are rotating around the x-axis. All right, so we have the volume is pi, the integral from 0 to 1. And so let's figure out what is the length of this first disk. And we can call it a disk. We're going to find the length of the second, or the radius of the second disk, the inner disk. And then when we subtract the radius from the bigger disk, or the smaller disk from the bigger disk, that gives us the washer. So always go from the axis to the whichever function you get to second. So that'll give you the bigger radius. And so this is just going to be x, and then we need to square it. So this comes from, actually we could just write, this comes from that. So x squared is not this x squared, it is this function squared, because we square the radius, pi r squared. Remember, our area of a circle. Minus, now the cross section for this one comes up to x squared. So now we have x squared squared. And that, of course, comes from this. All right, so I only point that out just because x and x squared, we got a lot of squaring going on, so we don't want to get confused. All right, so now we integrate. 0 0 to 1, x squared minus x to the fourth dx. And we get pi, integrate x squared, we get 1/3 x cubed, integrate x to the fourth, 1/5 x to the fifth. From 0 to 1, plug in 1, we get 1/3 minus 1/5, and the answer should be 2 pi over 15. Okay, so again, the integration is not the big deal. The big deal is how do you set up the integral. Setting up the integral is the hard part. Integrating it is not that hard. Just be careful when you get the fractions. All right, so let's look at the next one. And again, same idea. We're rotating about the x-axis, so the cross section is going to be perpendicular to that axis of rotation. So that is always the case with the disk and washer method. All right, so now we have y equals 1/4 x squared and 5 minus x squared, rotated about the x-axis. So we have 1/4 x squared. So the 1/4, if you remember from algebra classes, that makes a very wide quadratic looking graph like that. 5 minus x squared, this is going to be an upside down quadratic that has a y-intercept of 5. So again, it's a good idea to brush up on your graphing. You don't have to be super exact, but you do need to know that this comes up to 5. I mean, you need to know the basics and be able to sketch a decent estimation of the graph. All right, so now we need to figure out where these two intersect. So here is our shaded region, and we are going around the x-axis, so we have the cross sections going like this. Okay, so where do these two intersect? Let's set these equal to each other. Bring this x over, so we have 5/4 x squared equals 5 times 4/5 times 4/5. So we get x squared is 4, so x is plus or minus 2. So we're integrating pi times the integral from -2 to 2. Now, which function is on top? That's going to be our 5 minus x squared. And we're going to square that. Minus the bottom one. So minus 1/4 x squared squared dx. All right, so now we just have some algebra. This is nothing too complex here. So FOIL this one out. We get 25 minus 10x squared plus x to the fourth minus 1/16 x to the fourth dx. And I won't write the whole thing again. This gives us 15 over 16 x to the fourth. So now let's integrate. Pi, we have 25x minus 10/3 x cubed plus, all right, so 15/16 divided by 5, which would be the new exponent. So that gives us 3 over 16 x to the fifth. We're going from -2 to 2. I won't fill in everything here, but we get 176 pi over 3. So just for the sake of time, I won't write all that out. But plug in 2 and then subtract where you plug in -2, of course. But also, these are all odd functions, or these are even functions, we could say. And so you really just have to plug in 2 and then double it. You can use that. The fact these are symmetric around the y-axis, that helps. But aside from that, again, need to make sure we know how to set these up very well. All right, so the last one for this video, we have y squared equals x equals 2y around the y-axis. And again, that tells us we need to have everything in terms of y, and we actually do. So x equal both. So both these are functions of y. All right, so let's draw these. If you need to, you can write these in terms of x if you want for graph square root of x, in terms of at least to help with graphing if you want. Y squared equals x is just a parabola turned on its side like that. y equals x over 2. That's going to be a linear function like that. And so here is our shaded region. And we are rotating around the y-axis, so rotating around this one. Okay, so we need to figure out what is our limit of integration. So let's set y squared equal to 2y, and probably pretty easily figure out that y equals 2. So y is 0, y is 2. So v, volume, is pi, integral from 0 to 2. And so starting here, where do we get to? So our cross section again runs perpendicular to the axis of rotation. So the first, or the bigger radius would be the 2y. So again, we're writing these in terms of y, so 2y. So we have 2y squared minus, and then of course we get the shorter radius, that'll be y squared. So y squared dy. So 0 to 2, we have 4y squared minus y to the fourth. We can integrate this, and we get 4/3 y cubed minus 1/5 y to the fifth from 0 to 2. And so that should give us 32/3, 32 over 5, and that should give us 64 pi over 15. I'm going to trust you know how to plug in the limits of integration, so we won't bother with that a lot on the notes if it's too cumbersome. All right, so what are the key takeaways here? So let's remember that the cross section. So the way we're measuring the radius is the cross section is perpendicular to the axis of rotation. All right. If you're rotating around the y-axis, you need your functions in terms of y. If you're rotating around the x-axis, you need your functions in terms of x. And then we're utilizing the idea that the area of a circle is pi r squared. And r here is a function of x or y. So r is r of x or r of y, depending on which way it goes. All right, so just like the last one, practice these if you need to practice the disc method now, and probably once you have learned the disc method and you come to this one, you've learned the washer method, then maybe go mix them up and try a little of both and just see how it goes. But learn these before you move on to the next one again, because the next one is going to be a little bit trickier than this one. So all right, we'll see you in the next one.